All right, welcome back. So tonight's thing with parametrics is going to start off with second derivatives. So as a reminder from last class, we had said that to find the first derivative, you would be doing dy dx is going to be dy dt over dx dt. So that was our first derivative with parametric equations. For a second derivative, now we would have to get into the proof behind why this is because it's not quite as intuitive as you might think. Um, the second derivative essentially is you're only going to derive the top half of the parametric derivative and you leave the bottom half alone. And there's a lengthy proof behind why that is. But for right now in this video, we're going to just say that the second derivative is equal to d dt, which is take the derivative of dy dx, and then leave the bottom alone. So if you are taking the parametric derivative, derive the top of the derivative, and leave the bottom alone for the second derivative. So with that said, let's have you go ahead and write this down, and we'll do this first one together, and then I'll give you some time to try one on your own. But they're pretty straightforward. So if we're going to find the second derivative, we should probably start by finding the first derivative. So the first derivative is going to be, remember our formula, and that's dy dx is equal to, and then it's dy dt over dx dt. So that is going to be the derivative of our y term. Okay, so how do we take the derivative of something with e? This is chain rule. So this is e to the stuff times the derivative of the stuff. And then for the bottom, it's going to be the derivative of this is e to the 2t. So e to the stuff times the derivative of the stuff is going to make that a 6 because the derivative of my stuff is 2 and there was already a 3 out front. Okay, so we have located the first derivative. And now this question is asking us for the second derivative. So d2y dx squared, the second derivative is we're going to leave the bottom alone. And we're going to go ahead and rederive the top half. And that's going to be e to the 3t minus 1. And then that's going to be times 9 because we had a 3 out front already. And then we can simplify this because this would definitely land under multiple choice. So the answer we would have been looking for is 3e to the 3t minus 1 over 2e to the 2t. And we have a second derivative. Okay, next up, we want you guys to go ahead and try that. But now the question says, find the slope and concavity at t equals 2. So if we're going to be finding the slope, that's like the tangent slope. So this is going to be plugging into the first derivative, and the concavity is going to be plugging in to the second derivative. Okay? And you have your t value in this. This is all going to be for at t is equal to 2. Okay. So I'll stay quiet for, I don't know, 3 or 4 minutes, probably about 3 minutes. You guys go ahead and try this. So we're going to need both the first and second derivative, and then we'll go from there. All right, let's take a look at what you got. So I'll show my answers here. So I came up with the first derivative being 2t minus 8 over 4. And then when you plug 2 into that, we've got -1. Okay. And then for the second derivative, we should keep the bottom and derive the top. That takes us to 2 over 4, which is a half, and a half is greater than 0. Therefore, it would be concave up at t equals 2. Does anybody have any questions on that? Okay. My next one is another example of the same thing. Go ahead and do it real quick. Just make sure you got it. But we won't spend much time waiting for you on this one. So take about 60 seconds, and then I'll put the answer in. Find the slope and concavity at t equals 3 for the thing that you see. Okay, so did we get -24 and -17 for our answers? Okay, I see some heads nodding out there. So concave down because it was a negative, and then -24 on the slope. Any questions there?
If you answer this like on an FRQ, would they require you to actually like for the second derivative put the numerical answer, or if you can just look at it and see that it's concave down, can you just write concave down if you have the like equation?
So if it's a free response, best I can tell, you need to at least write something about, I don't know that you would necessarily have to say like -17. I think you could say something like d2y dx squared is less than 0 at, what are we doing here? T equals 3. Therefore, concave down. I think that would fly. But you got to make some kind of statement that you understand that concave down means the second derivative is negative. I don't know that you would have to show the exact value of it, but I would do at least something like this. Okay, so that takes us to, give me one sec here. All right, arc length of parametrics. So we've got a formula. To find the arc length of a parametric. To find the arc length of a parametric. So this is a formula that you're going to have to know. If this will likely pop up in free response. And if you know the formula, super easy. So before it's all done, I'll get you guys a sheet with all of your BC formulas on it. So you got stuff to study. Kind of like the backboard in my classroom that has all the formulas. We'll make one of those for BC. So the formula here is the integral from a to b of the square root of dx dt squared plus dy dt squared. My guess is you'll see this, you could see this in multiple choice as well. This is one that's a pretty easy question for them to ask, just tests, the formula. So with that said, let's give it a try. Find the arc length on 0, 2. Now, another thing about these is that they often appear in the calculator multiple choice because these integrals are usually kind of crazy. So it's something that when we go through this, you'll see it says use calculator in my notes. So just get the setup. And then usually this free response or multiple choice involves plugging it into a calculator. So if you're going to get those, we should find dx dt and dy dt. I've also seen questions asked for where it says which one of the following represents the arc length. Taylor, what's up?
Shouldn't it be 4t squared?
Yeah, thank you. I've seen it asked where it says which one of the formulas represents what you're looking for. And then you would have 4 different formula setups. And one of them would have had 4t instead of 4t squared, and seeing if you had everything accurate and stuff like that. And you just pick the one that would make sense. So all you really got to know for this is just know the formula, and the rest is pretty straightforward. Okay, any questions there? All right, then let's get into some crazy math. Then this will keep you busy here for a 9 o'clock on Thursday. We are looking for arc length. So give me a formula here. Let's find it. Okay, now this is regular arc length. This is not parametric. This is just a regular old arc length, but it kind of goes into the same unit. And the formula for it is listed right here. So we have parametric arc length and we have regular arc length. Okay, and this is a doozy of a problem here. So we want to find the arc length of the following, and we got to keep in mind the formula up above. So before you jump into the formula, you kind of want to go off to the side. I say, I'm going to kind of separate this, and this is going to be my side work or my scratch work over here. And what do we need to figure out? So of course, we're going to set all of this up, but we need to locate the derivative and we need to square it. So we need to locate the derivative. So that's what I'm going to do over here. So the derivative would be equal to, if we bring the 3 out front, that's 3 over 6. So that's a half x squared. And now in your head, or if you wanted to rewrite it, you could. But we should be thinking of this as half x negative 1, because in order to derive that, we've got to bring that x upstairs. All right, so now when we take that derivative, that's going to be negative half x to the negative 2. And now we're going to clean that up and flip that downstairs. So the derivative is equal to half x squared minus 1 over 2x squared. All right, so that's our derivative. And now also we want to square our derivative. So if we're going to square this, that essentially means we are going to take this and multiply it by itself. All right, so this is basically, we're foiling this. It's just pretty messy. So take a second, try it, foil it, see what you get. Stop after you foil, because then we'll talk and get back together. But go through and try and foil this and see what you get. Okay, did we come up with something that looks like that? So first times first was 1/4 x to the 4th. And then the outer and the inner each gave us negative 1/4, because this x squared and this x squared would actually cancel, right? And then a half times a half is a 4th, and a 4th minus a 4th is negative 2/4, which is really negative half. And then last times last gave us 1 over 4x to the 4. Okay. So we need to kind of get this smushed together so we can kind of simplify this. So we need to give this a common denominator. And the common denominator between 4, 2, and 4x to the 4 is going to be 4x to the 4. So now the question becomes, what did we do to each piece to pull that off? The last one, we did nothing. This one, we multiplied by 2x to the 4th. So we're going to multiply the top by 2x to the 4th. And this one, we multiplied by x to the 4th. But we already have an x to the 4th, so that makes x to the 8th. Okay, so now that we have a common denominator, we can write this as x to the 8th minus 2x to the 4th plus 1 over 4x to the 4. All right, so what exactly is this that we found here? This is the derivative, and we squared it. So this piece right here, that represents y prime, the derivative squared, or f prime of x squared. So into our formula now, what was our formula? It was the integral of 1 plus the derivative squared. So we already went and found this piece now. So now we're ready to actually use this formula. So it's going to be the integral. Our bounds is half and 2. We're going to do a radical, and then it's going to be 1 plus the derivative squared, which we just said is x to the 8th minus 2x to the 4th plus 1 over 4x to the 4. All right, so our next step is going to be to get these combined. So if I give this a common denominator, think of this as 1 over 1. We need to make this 4x to the 4, which makes this 4x to the 4. So if I turn that into 4x to the 4 over 4x to the 4, we can then add that to what's over there, which is going to give us, we add the 4x to the 4 onto the negative 2x to the 4, that should turn this into the square root of x to the 8th plus 2x to the 4th plus 1 over 4x to the 4. Okay, we're getting there. The next thing that I see is that the top of this is now factorable. We could factor this into x to the 4th plus 1 quantity squared over 4x to the 4. Don't forget, these are all integrals still. Okay. Next step that I see, you can split a square root into, in other words, the square root, if I tell you off to the side, the square root of a over b, that's equal to the square root of a over the square root of b. You can split those. So if we split these, this would be the square root of x to the 4th plus 1 squared over the square root of 4x to the 4th. Well, that's helpful because these can both simplify now. If you take the square root of something squared, you're just going to be left with x to the 4th plus 1. And on the bottom, we're going to get 2x squared because you can take that square root. Those are both perfect squares. Okay. So now we're actually finally ready to start integrating after all of that math. Does anybody have any suggestions out there? Any ideas for what sort of strategy we would use here?
Split up the 1 plus 1.
Yeah, exactly. Split them up. Exactly. So we can just split these up and we're going to call this x to the 4th over 2x squared plus 1 over 2x squared. And then this is now going to be the integral of x squared over 2. And then the other side is going to be, we're going to just call this x to the negative 2 over 2, because in order to integrate that, you have to flip it upstairs, right? Dx half 2. Okay, so that's a lot of math. I'll try to zoom out in case you need to catch up on any of it. That's everything we have done so far. And now I'm going to give you guys a couple minutes, 3, 4 minutes, 5 minutes, whatever you need. Let's go through and have you finish the problem up. So you guys should integrate these pieces, plug in the bounds, and let's see what you get. Okay, does anybody have an answer out there that they want to share? Any brave souls?
I feel like there's so much math and this is probably definitely not right, but 2.125.
2.12, hold on, let me see here, because I did a fractions, let me see. We're close, what's 2 point? That's what, 2 and an eighth?
Yeah, that sounds right.
We're real close, but not quite. I mean, maybe, let me check, I can double check my math as well. There is a ton of math here. Anybody else get an answer that confirms that or got something different? All right, here's what I had. I had 33 over 16, which is 2 and a 16th. So it's,
That's what I got.
which one, Taylor? 2 and a 16th?
Yeah, 2.0625.
Okay, so let's see here. So I mean, you're super close, Bronwyn. When you integrate this, did you get to this would be the first step?
I kept the 1/2 outside of everything, but yes, yeah,
Same thing though?
yes.
Okay, so then when we plug into this, we're gonna plug a 2 into it. So that's 8 over 6 minus 1/4. And then sticking to this side of this, that's 16 over 12, 3 over 12. So the left side of this is 13 over 12. And then on the right side of this, if we plug in a half to the third is an eighth, and an eighth divided by 6 is 1 over 48. And a half over here is 1 over 1, because 2 times a half is 1. So this is 1/48 minus 1, which is negative 47 over 48. And then common denominator between 12 and 48 is 48. And then you need to take that times 4. So then I got 52. So I got 99 over 48, which simplifies to 33 over 16.
Got it. Okay, I messed up the signs when I was because I was distributing the 1/2.
Gotcha.
Okay. Yeah.
Yeah, honestly, guys, so I mean, I just wanted you to do some math, but I don't think they would. That's pretty aggressive. That math we just did, that's a lot. What they will do is same thing as the other one. They'll ask you for which one is the setup. So if they ask you for the setup of arc length, this will definitely be what you would need, is to at least put the setup that is correct. So compare that to the other formula you had. Your big takeaway for tonight is we learned 3 formulas. So you should have a second derivative formula. We should have, so exiting parametrics after these last 2 nights, there's still some more we're going to do with it, but we should know how to take the first derivative. We should know how to take the second derivative. I think it's the same paper, excuse me. While we're looking at it though, horizontal tangent is set the top to 0. Vertical tangent is set the bottom to 0. We should know how to take the second derivative. So that's going to be derive the top of the derivative, keep the bottom. We should know arc length of parametrics. Oops. And that's going to be the radical of dx dt squared plus dy dt squared. And then the most recent formula that we just looked at, which was going to be the arc length of regular, which is right here. So those are the formulas you want to keep in mind for what we've talked about so far. As we start moving into some other stuff here, we're going to look at some free response questions that have been previously asked using parametrics. That's a pretty popular question they tend to use. So on Sunday night, we'll look at some of that. Do you guys have any questions or anything for me? All right, sounds good, guys. So just make sure you're keeping notes and keeping track of all your BC stuff. I do not see you guys tomorrow, so enjoy your weekend. If you're free and you want any help, feel free to come see me. During advisory, I will either be in my room or B205 like the other day. If we get too many of you, then we'll head over to that room. So if you want to, I will see you in the morning. If not, enjoy your weekend, and we'll meet up next time is Sunday at 8:30. So see you guys later. Have a good night.
Thanks.